Hi, welcome to Anvil Repairs. My name is Kyle, and today you'll see the product of about 6 months worth of work. This is a Joseph Wilkinson anvil, and it started with me looking like this. So if you want to stick around and see how I accomplished this task, you're welcome to. If you would like to see more of these types of restorations, then I'd suggest you subscribe, because as you can see from this picture, we've got a few anvils needing repair. So I wanted to just quickly chat to you guys. I've tried my best to make this video as short as possible, so I really apologize for the length. I did try and document as much as possible on my theory and what was going through my head when I did certain things on this restoration. If you guys are wanting to do a restoration on an anvil this extensive, you sort of know what I'm thinking, the reason why I'm doing certain things, so that you can apply that to your restoration. There's no point in you paying school fees when I've already paid school fees plenty on these types of restorations. This one went a lot easier than my first one, and that's just because the first one I had no experience, and there's nothing on YouTube with this type of repair. This one went a lot easier. I brainstormed a lot more, and I've tried to explain that in the video, so I really apologize. You're welcome to skip through if you're not really looking for that much information. If you're just wanting to see the end product, then you're welcome to just skip through and then have a look at how I did things. But if you are wanting to do this type of restoration, I have documented pretty well what I thought necessary. So without further ado, let's get into it. Right near the end of the video, I factored in things like cost of material, time, or you already know time was 6 months. Because I didn't do this from start to finish, I did it in between other things when I had some spare time. Restoring anvils is not my day job. For those of you who are newcomers here, I have an import business and I have a foundry next door. So when I have time, I like to do these things. The reason I like to do this is because these broken anvils, like for instance this one was broken, the whole heel had broken off, the face was wrecked, the cutting table was almost non-existent, the horn was flat. People could not use this anvil other than to just bash stuff around on it. It wasn't a usable anvil for a craft. So I really enjoy the history on anvils. I enjoy the fact that this is so old and yet I've been able to fix it and give it a second life. This anvil will now outlive me, and it'll bring someone a lot of joy, and someone will be able to make a decent amount of pocket money or a living on this anvil. The face is better than what it was when it came out the factory, most likely. You'll see in the video right near the end of the little blemishes that are still left, but it's very minor. So enjoy, stick around until the end of the video, and then you'll be able to see all my costing and everything like that after we finish the repair. So the table is all oiled, and this is 3 days later, and it's fairly dry. It's a little bit gummy in places still. You can see my fingerprint there, but can't wait any longer. So I have a little bit of time. I have an hour now before we finish work, so I'm going to just start to grind out all of this and prep these surfaces, welding just with a small grinder. I'm not going to do this here because this will require the big grinder, but I'd like to just see. I have an idea that there's some delamination in there, so I'm going to just I'm going to just work a little bit and see what's going on here. I've got this deep crack. There was a crack that ran back here, and I've got that out now. But there's this very deep crack that's running
from here, and I've been trying to, it's on this side here, and I've been trying to grind back to see if I can get rid of it, but it's actually now chasing back like that. So I think what I first suspected, I think that this whole piece is basically broken off underneath on the wrought iron. So I'm going to cut it back now here and then see if I can lift that off. This is the worst side here. This side, it doesn't look like there's too much delamination. It's just obviously broken edges, cleaned up over there. But yeah, this here has to come out, I think. So that's what I'm busy trying to get out now. What I've done is I've cut through the faceplate there and there, and I've cut to the top of that crack over there and to the bottom there. So I'm hoping now if I chisel it from here, that part's going to pop out. I've never done a big one like this before, so we'll see how this goes. See, it's definitely starting to pull forward. There, it's cracking, see, so it was all the way down there. So you can see how it was cracked on the wrought iron. The faceplate that was welded to the wrought was the only thing holding it on. Now I'll just carry on grinding in here, grinding in here until I see that there's no more cracks, and then I'll be sort of happy here. But I think I might even have to come down a little bit more until about there. So I'm going to try and see now, because I see another crack. I also see that the crack is running quite deep in there, so it might be that this whole piece has to come out. I don't know yet. We'll have to obviously just carry on doing this and then see. But I think what I want to try and do now is I want to try and hammer in there to see if I can get this lifted off, even if it does mean that it peels off here, just so I can see how deep this crack runs. It seems as I was right. You can see there where it's starting to break away up to there. What I did is I just sort of I saw where I had cracks here, and I saw that I'd had cracks here, and I thought, well, it's very possible, just judging by the sort of angle of that break, and obviously we saw that there was a break in there, so I just guesstimated that the crack ran along like that. I don't have any special tricks or anything like that. This is obviously a bit different. This is actually a break in the wrought iron. Normally it just has face delamination, whereas the face is still bonded to the wrought. It's just that the wrought has cracked. So I don't have any special tips or tricks for you guys here. It's just I'm sort of just trying to see where the crack runs. You can see now that it's separated a little bit, you can see where the crack runs. It runs along. It looks like it still even comes back into this more. So now what I'll do is I'll follow that crack over there. So I'll get this off and I'll see where that crack is, and I'll follow that back. And I'll just keep on following it. A lot of the time, sometimes I know there's a guy in Canada that does this. Half of the face comes off, And that's the thing with restoring anvils, is you just sort of never know what you've got, But if you want to do it properly, this is how you do it. So obviously all this has to be now built up with welding. It's not a lot of work. No, it's once you get going, it goes. But yeah, some guys are not cut out for this type of thing. Well, I love this. This is awesome. So I'm not going in directly like that. I am angling the chisel a little bit so that it pushes this chunk outwards. I want it to break on out. I don't really want to, because that'll just be more work. So I'm actually trying to push it off rather than open up the crack. You know what I'm saying? There she comes. Cool, so it looks like we've got it. You can see it was bonded. That over there was steel. There's no rust there, which means, I don't know how well you guys can see this. Let me just see. Okay, no, you guys can see it pretty good. So there's no rust over there, which is the corner where it broke off. So that tells me I've chased the crack to where it ends. You know, the crack obviously ran through here. However, this broke off. It was obviously quite violent the way it broke off, and that obviously separated and cracked along with it, but this didn't break off with the heel. The heel would have broken off, and yeah, obviously that would have just been left cracked. But I mean, you can see the rust in there. It's not like I've been imagining this. There it is. So basically now we prep all of that. We get it nice and clean, and then we can weld it. There you have it. That is what came off. That was delaminated, and we will now replace this with good new steel. Okay, so I think the last time you guys saw this, it was sort of around about there. I chased cracks. Not only cracks, there's obviously, because this is wrought iron, there's this like flux, I'm guessing, that they use to forge this stuff, and I'll just ground and ground and ground to try and get rid of that flux, and it just seems that it just goes further and further down. So I mean, I'm already, what is that, probably 3 inches, I'm guessing 75 mils down into the body of the anvil. So I mean, I don't know how much further I must take this. So you'll see I'm using a whole lot of small little grinding discs, and I use them until they're that size. And the reason is over here in these little spots, that grinding disc fits perfectly in there if you work it back and forth. Whereas on a bigger disc, you know, you have to take out a lot more material in order to get to the tight little spots. So like in there, you know, you just put the little grinding disc and you just work it, and then that's the reason why I use them. Same as like over here, I'll use a small little grinding disc. Just a quick one. So what I'm going to be doing is I'm going to be putting this upright so that when I cut, I'm using the weight of the grinder to cut. I don't have to hold the grinder horizontally. I'll be cutting down vertically, and I'm going to be climbing on top of my table and just, you know, slicing it down. Just for those of you guys who say, watch your back, I am aware of that. It's just, this is going to be the easiest way. On the table, at least, I don't have to pick it up and down off here. Much easier for me to just climb up there. Okay, so there you have it. That was a long process. That took me probably, I would say, about 2 hours. I tried to work this one out a little bit more. I've got to the bottom now, but I'm battling to get in more, so I might just use a die grinder and just clean that up so that it's clean steel. I don't want to carry on going more because the big grinder obviously takes a long time because I have to remove all this material in order to get in there, and yeah, my small grinder can't get there. Finish that up with a die grinder. The face, I had cracks running inside the faceplate this way, so I just ground until they're gone. Over here I had cracks running down, so I ground until they're gone. And then the horn and the cutting table, that's all wrought iron. You can see there is a slight crack in the wrought. There you can see it. I'm not going to worry too much about it though, because that gets built up with normal mild steel. This doesn't get worked very hard. It shouldn't get worked very hard. So yeah, I'm not going to worry about that because there's not, it doesn't look like it's too deep, and there's no point in me going down too much over here. A little bit over here, those are just the bottoms of the chisel marks. So I've got to just go down there a little bit more. But other than that, she's pretty well prepped. A lot of prep work. If you ever ask a question, is it better to restore an old anvil that's badly damaged or just buy a new one? It's better just buy a new one. or a less damaged one, but I do this because I don't see the point of putting this thing on the scrap heap. It hurts to think that this was made in the mid 1800s, and yeah, I don't think things that old should be chucked on the scrap heap. What I'll probably do now is I'll just flap a wheel alongside here, you know, so that when I do weld, it can not, I don't get any porosity or weird stuff happening there. So I always clean my area quite a lot around where I weld. That too, over there's going to be a bit of a problem. But what I'm going to do is I might just leave that. And then if there's a bit of porosity there, so be it, you know, it's not structural. It's always best to just have absolutely as clean a steel as you can have for welding, because yeah, any impurities in here will obviously just cause problems. So, but yeah, that's it. Happy with the way that turned out. How it's going to work is this will all be built up with mild steel, normal MIG wire, you know, your standard mild steel MIG wire, because this you don't want to be hard. If you are going to be chiseling and stuff on it, you don't want to keep on blunting your chisel like mine is from trying to chip out, you know, on tool steel stuff. So you don't want to use hard facing here, just use mild steel. It'll serve its purpose. From here on, obviously all this will be built up with mild steel till the top over here. I'll explain that just now, and then obviously all this building in here, all mild steel. Okay, once I've got all the mild steel done, I'm going to be left with obviously this stuff over here going on, whatever's going on here on the face, as well as the new heel. This, I'm going to try a new method. My welding supplier said that it's a good idea to do this. I explained this earlier on in the video, I think it's this video, where obviously this is quite hard already, but that is normal mild steel, so that's quite soft. All the building work is going to be mild steel, so I mean that's going to be a huge chunk in here where it's going to be soft. So I'm going to go over this with a 903 stainless, it's called a 903 buffer. So that will be my intermediate layer between soft over here in this case and the hard facing. So that will just give the hard facing support so that it doesn't crack and do weird stuff. It doesn't normally crack too badly, but there's always hairline cracks just because of this being quite soft and then the tool steel the hard facing being very hard. So yeah, I'm going to try that. I haven't done it on any of my other anvils. I've just normally gone mild and then hard facing, but I'm going to try and do that. So all this build up over here, I will do with that new buffer rod to get that nice and hard. And then afterwards, I will grind it down. It doesn't have to be absolutely perfect. It doesn't have to be flat. It just has to be not like this. And then I will put my hard facing, and then we'll prep the whole thing. So yeah, this anvil is going to be a little bit different to the last one I did. Obviously there's much more damage over here. This is a bigger anvil. I think this is close on double the weight of that other one. So yeah, but there was a hell of a lot more damage. I mean, the other one was basically a clean break. I cleaned it up, there was no cracks, welded the new heel on. Whereas this one, I had a lot of weirdness going on here, and you know, there's a lot of cracking. I think this could be possibly maybe an earlier, or the wrought iron quality is worse off, because the wrought iron over here, there's a lot of cracking and stuff going on. So I don't know. I mean, Wilkinson anvils are generally very good quality, but I don't know. I don't know what they had access to back in the day. No judgment from me. They did bloody good work. 100 and something years later, their anvils are still around. We take it next door and start tacking everything together and laying it out and seeing if I'm happy with the shape. Okay guys, this is the next day. Just in case you're wondering what all the writing down and measuring was about, I was just getting a halfway mark on both. Obviously the horn, I did double check it. The horn is in fact middle of the anvil, and then I've drawn a line all the way across the halfway mark. The anvil is, how much bigger is it here? I think it's almost 8 mils bigger. Don't ask me what that is in inches, but yeah, it's got 8 mils big on this side than it is on this side, which is fine. Measured that. So, and then I drew this line over here. So I'll put I'll line everything up so that that line is on the middle, the other line is on the middle, the anvil is on the middle, and the horn is on the middle. Get everything lined up, and then I can tack the horn onto the anvil. I'm here alone today, which is really nice. So I have the whole day. It is now 20 past 8 in the morning. So we'll see. I'm hoping to maybe get the welding done today, at least all the mild steel welding. Okay, so I'm ready to tack the heel on. What I was doing is I just took some scrap square tube, welded myself a square that I could obviously weld on and get all messed up. I just try to see at first the gap between, obviously, I mean, it's fatter here, the body, than it is at the face. So I was just trying to see the gap, and I thought, actually, you know what? Let's rather make this level on the feet, because then all I do is once I grind the face, all I do is I just put my level on the face and then check for level, you know, this way, that way, and then I know if I'm square with the feet. So I thought that'll be a good idea. So the feet are off, obviously, of course they are. So this one is ever so slightly off that way, and this one is ever so slightly off that way. So I've sort of tried to get them in the happy medium, or whatever you want to say. This is off, but let me show you. So if I take this little spacer out, then it is absolutely perfect there. But then, okay, and then that's perfect over there, but then this foot over here is out quite a lot. So that gives me two options. Either what I could do is space it so that it's sort of right in between in the middle, or I would have to take this foot down by 4 mils on the outer edge, which actually might be a good option, because then I've got this thing perfectly level. Let me give it a little bit of thought. I think I'm going to just grind this foot down. There you go. See, this is why I talk to you guys. Okay, so let me just think about this quickly. I think what I'm going to do is I'm just going to mark from here to there, get a level line, and then see how much I'm going to have to take down on this foot. I've done this on one of my other anvils before, where the foot was way off, and I had to grind the 1 foot down. So let me just do this quickly. There's the anvil from the top. See how much welding I've got to do there. Okay, so I'm just thought I'd show you quickly what I've done here. I made this little tool. It's basically just a piece of pipe that I've cut wedges in, and then I shove a piece of chalk and then I break it off, so then I can sort of trace, you know, along here. So anyway, I traced all that. He took it down to the foot. The waist. What am I talking about? This is the important part. Okay, so what I've done here, I traced up to here. I traced that to where it breaks off, and then I've just drawn myself a little line, because that's obviously the shape that we're going for. Remember, we cut the heel, according to the sketch that we had on the big cast iron table. So I marked that, so I know that this shape is roughly what I need. I might need to just grind it slightly in there to make it more, you know, rounded, but this shape is roughly what that point over there is correct, and that point over there is correct. We might just need to take a little bit out there to give it that rounded, nice smooth look. So anyway, so that is what needs to be filled. Now, I have two options here. Either I can just start preheating this thing and welding it. As you can see, I still need to just diagram that out. Haven't done that yet. Okay, so I can just preheat this thing and then start to weld. Or what I can do is I need to chop this block down by 10 mils over there. So I need to at least sharpen that angle quite a lot and then bring it to about there, like that, you know. So I need to chop all that material off and throw it away. And then cut the heel off, preheat the heel, preheat this, weld that on. Then once that's on, weld it to the anvil. Now, this is not very heavy, so I think that would just be sort of defeating the object. I don't know. It feels like I'm going, I'm walking in my past footsteps here, because I try to do things a little bit differently with trying to escape so much welding. But at the end of the day, I mean, it's welding. So I think it's going to be easier for me to just actually just start preheating and then just give it stick. Yeah, and then just fill all this up, because I mean, I have to fill all that. Sorry, my camera angles are shady. I have to fill all that up, and then I have to fill all that, you know. So I have to fill anyway. So I don't know. I don't see what the point of that would be, you know, where I have to, I mean, that material, there's more that I have to fill in here than the mass of that material over there. So, I mean, I'm going to be filling. So, you know what? If I'm going to be filling, then I might as well just start filling. Quit beating around the bush. So that's my thinking. Obviously, that over there, I think what I'll end up doing is I'll just come in with a big cutting disc, and I'll just snip that down and then clean it up. You can see over there, I've sort of dialed in where the high starts. You know, you can actually see, look at that. You can actually see where I've been dragging around on my table, the high. Look, that one over there and that one over there is also a little bit, but this one over here is much more so. So anyways, that tells me that my theory is sort of correct. There is a high spot in here. So what I'll do is I'll cut down and then I'll just grind that out. I don't think I'll ever be able to get it perfect. I don't have like a surface grind or something, but I'll get it closer than what it is now. But that will come after everything else. Yeah, today I need to focus on this. So yeah, fun times. It is now 9 o'clock. So I think I'm gonna just give this one more tack. I tacked it from the back, so I'm gonna tack it in here. That's not my, don't worry, that's, I can definitely see that there's gaps there. Don't worry, it was, like I said, tacked from the other side. So what I'll do is I'll just burn that in there now, burn that in there, get that nice. Yes, I do have a gap there so that I can get a full penetrating weld. That's the whole point of doing all this work, is so that there's no holes. You know, you don't want any air gaps, as little as possible. On my welding, I don't want any air gaps. In this mass over here, guaranteed there are air gaps, as you can see, that are still in here, but it's, yeah. As long as I can put out that my work is solid, you know what I'm saying? So anyways, cool. I'm gonna stop blabbing on. I'm gonna tack this. Yeah, and then I'm gonna tack this, and then I'm gonna pretty much stand it up, get it set up on the table so that I can start preheat. I want to just quickly show you guys what rods I'm gonna be using. Okay, so let's start with what wire we're using. This over here, this is just a new box. I've got a roll currently in my machine. This is just a 0.8 mil normal mild steel wire. That's like your pretty much most basic wire that you can get. Then second, we have this, which I've never used before, so I'm going to give it a bash. I've seen some of the guys in the welding group say that I can't use mixed gas, I have to use pure CO2. The only pure CO2 I have is food grade CO2. So if I really battle, I'm going to bring in my food grade CO2 and see if that makes it weld any better. But anyways, so this is a stainless wire. It is a 309 buffer. Guys, I'm not a welder. I can weld, but I don't understand what that is. So don't ask those type of questions. All I know is that I spoke to my welding supply store and I said, listen, I'm welding anvils. I said, they're wrought iron. He said, okay, no, that's fine. Weld, do all your full work with normal mild steel. Then underneath your hard face, do a 309 buffer, which I bought. That was quite expensive wire, but it'll last me a long time because I only use it on the face underneath the hard facing. And then he said, the third off, use a hard facing rod. So They don't have stock of hard-facing welding wire. I would have loved that because it'll get me done a lot quicker than this. This takes a lot of time. Anyways, they didn't, so I had to buy myself another box of this, which is what I used last time. It's a Gemini H600R hard-facing rod. It's a 3.2 mil. They weld really nice. They go on super nicely. So I've never had a problem with that. I know how to use them. It just takes time, obviously, because it's arc. It would be much nicer if I could just get a MIG wire and then just bash it on there on top of this. But anyway, today is not going to be that day. When they do get stock, they'll phone me and then I'll buy myself a roll of the MIG hard-facing wire. So then basically I just change my rolls in the machine and I'll just carry on going. I will show you the settings on my machine. Last time you guys asked, you said, you know, sort of what amperage and what voltage am I welding at. The truth is, I don't know. So there my machine is. It's a 250 amp MIG. Yeah, Pro MIG is the brand name. There it is. Your typical made in China type machine. I've had it for, what, 8 years now, and it's never given me any problems. So there it is. It'll give you the voltmeter and ammeter reading when I'm welding. So what I'll do is I'll get it. Normally I just play with it. I know my machine. Oh, I know my car. I know how much I can go on a empty tank. Anyway, so basically I just know my machine. I know that when I'm welding heavy stuff like this, thick stuff, I need to be around about there, 5. Normally what I do is I up my voltage slightly and then I'll leave my amperage about there. I might even go to 5.5 over there, and then I'll boost my voltage up to 6. Wire speed, guys, that's my controls. I don't know what wire speed it is. Normally, as far as I understand, it adjusts the wire speed accordingly. I have a switch over there to say what sort of, what wire I'm using. So obviously I'm using 0.8. 2-step and 4-step, I'll be welding on 4-step just because then I pull the trigger and then it auto feeds until I pull the trigger again. 2-step is when you pull the trigger, it feeds. When you let go, it stops. So because I'm going to be doing a lot of building work, I don't want my finger to cramp, so I'm going to be going 4-step. But I'll show you guys all of that when I'm actually welding. Another thing I thought would be cool is showing you how much electricity I use. Because I'm here alone today, I have everything off. I don't have any lights on. I don't have anything on at all. So I have 100 units of electricity. Now, I think this is a pretty much standard thing. So you guys will be able to figure out how many units you use. We are obviously 220 volt. I know in America you guys are 110 volts. I think the units stay the same. I don't know. You'll have to comment down below and tell me. But yeah, so we've got 100,1 units. Kilowatt hours. Okay, so I will video after all the welding is done, and then we'll see how many units we've used. And then you can figure out how much electricity costs in your area, and then you can work out what your total consumption of your total cost on repairing an anvil will be in your area. Thought that would be quite cool. For preheat, okay, so you can see we've got gas lines over here. Our gas chamber is outside where we've got LPG gas, the big 48 kg bottles. So what I do for preheating my anvils, I have a hose like this over here with a male and a female clip on it. I clip the male side into this regulator over here. I open it up. There we go. I've got my gas. Then I plug this torch in to the female side, and it's just your normal conventional trigger, torch. And what I do is I put it in a vise, and then I open the gas all the way. For measuring, I use a little gauge that I can it's a little digital gauge you'll have seen in the previous videos. I'll use it again today, and that is how I measure the temperature. I want it to get around about 200 degrees. Keep in mind, obviously we have a crap ton of welding to do, so it is going to get it is going to warm up. So I might warm it up to about 200 on the heel, because obviously it does differ, the temperatures. When you're heating it up, the body is always colder because obviously it's a huge mass of steel. The heel and the horn heat up quicker. So I focus my flame on the body. Then when it's cooling, the horn and the horn and the heel cool off quicker, and the body stays warm for a lot longer, again, because of the mass. So I have to just keep that in mind. So what I'm going to do is I'm going to heat up the body to around about 200. If it's like 180 or 170, it'll be fine. But the problem is that when I heat that up, the horn and the horn and the heel are going to get hotter than that. So I don't want to overheat the horn and the heel. So I have to just, basically you'll see I always take 3 readings, 1, 2, 3, 1, 2, 3, and then I just see what all the temperatures are, and then I can't say to you that it's critical on how much preheat you're putting in. All I know is that obviously you need to preheat it because you need your welds to penetrate, especially into your wrought, really well. So yeah, I will be, even if I have to preheat the whole body until maybe 180, and then I just heat up where I'm actually going to be welding, and then I can start welding. Because once I start welding, then obviously all that heat is transferring into both pieces. You'll see I might need to take a break here and there. I don't know if you'll see it in the time lapse, because obviously it's time lapse, but I will take a break if I see it getting too hot. Then I'll take a break, let it cool down a little bit, and then carry on welding. Generally, I don't really need to, because the heat transfers through quite nicely. After I'm finished welding, I don't think I'm going to be able to do all my welding today. There's just too much. It's much more than it was last time, and last time took me a full day. So what I'm going to do is I'm going to do all of my building work with my my mild steel today. I'll see if I have time to do the buffer, the 309 buffer on the face. If I don't, it's not a huge deal. I will put this anvil in my sand. Yes, I don't know. I don't have staff today. I'll ask one of the guys next door to help me. And yeah, we'll put it in the sand and then basically cover it up, and that'll hold its heat until tomorrow. Tomorrow, I can then pull it out the sand and again, just put a little bit of preheat on it, get it up to temperature, and then start to do the face. Okay, so that's the plan. I'm going to go and change my shoes so that I can wear my shoes that I don't mind getting stuffed. And then I'm going to start, actually I'm going to preheat, I'll preheat now. I'm going to put this on preheat so that it can start getting hot. I'll go and get changed, get ready, and then I'm going to come and start welding. Cool. Thought I'd quickly just show you guys how much water these things retain. Have a look over there. See the water dripping out of the anvil as you start heating it up. Obviously they just retain moisture, you know, like anything, but yeah, another reason to preheat. Okay, so we are getting there. I'm concentrating a little bit more heat now on the heel. The body is around about 120, so it's not quite there yet. But I have had it both sides. Where it's glued a little bit over there. It's not an issue, but yeah, it is getting there. I'll put the camera in the tripod now, and then I'll show you guys how I test the temperature. The horn is not very hot. I haven't, okay, it is a little bit hot transfer, but hot enough that I can still touch, you know, it's not going to burn my skin off. So I haven't concentrated any heat on the horn yet, because that'll be last, you know. I will put a bit of heat on there just so that I don't get any like major differences in temperature between the body and the horn. Yeah, as obviously the horn is forge welded on, so there's always a possibility of breakage. Basically, I just keep on moving around like this. Letting the vise loose a little bit. There we go. Sorry, I'm trying to do that one hand. Anyways, yeah, I'll take a few temperature readings, and when it's about there, then I'm gonna give it a stick. So you'll see it right at the beginning, it's the same as the other anvil. I'll do it like a pass here, and then flip it over, and then another pass, and I'll just keep on flipping it over so that the heel doesn't pull either way. Once I've got, I don't know, 10 mils worth of welding, it's not going to pull much anyway, so then I can start, you know, actually filling. About on the other side that I'm heating up now, we're about 140, and then this side we're about 160. So we are getting up to temperature. I think I'm gonna take it to about 180, and then I'm gonna start welding. The temperature pretty much. I thought I'd try and show you guys. So that's ambient temperature, 24 degrees Celsius. Let me see what's Fahrenheit. Okay, so it's a 76-degree day today. It's quite warm. I am gonna test this in both. So let's see the body. Around about 140. And then Fahrenheit, let's just see what that is. Okay, no, it's not reading Fahrenheit. Sorry, American folk. Let's see on this bevel over here, which is where we'll be welding. Around about 170, 180, that's cool. There you go, 180. Perfect. Okay, what I have also done is I've got this little bit of U-channel. I'm gonna stand the anvil on its feet, and then I'll lie the body over there on there so that I can have it as level as possible for when I weld. What I also wanted to show you guys is gas. Okay, so normally when I weld with my gas flow right around 10. You can see there, it's right around 10. I am going to boost it up to 15 just for these first few welds. I'd rather have too much gas flowing down into the bevel. Because it's hot, obviously I don't quite know, like I said, I'm not a qualified welder, so I don't quite understand the theory of how everything works. My idea is that the anvil is hot, so naturally it's going to want to push that gas up. So I rather just have more gas so that I get a good insulated weld, especially there in the bevel. Once I've started to weld, otherwise, then it should be fine. But anyways, so I thought I'd just let you know about that. All right, I'm going to try and struggle with this thing now. Put my gloves on, put my welding coat on, and I'm going to try and struggle getting this thing down so I can start welding. Okay, this way you guys will be able to see my voltage and my amperage while I do my first pass. Okay, so there's my first pass. Not great, but not too shabby. A little bit of porosity over there. I'm going to flip the anvil over now and then do the other side. Thought I'd just show you what that weld looks like from the back. There you go. So you can see it did drip through a little bit. So now I'll wire brush it, and then I'm going to give it on top. And from there, I can trust that it's not going to pull too much. So then I can start welding up. So I'm just going to do little snippets in between. You can see the machine is welding really well at exactly the same settings that I had it earlier. Yeah, got about 20 mils now, so that's cool. I'm going to just carry on filling it up, and I'll just take little clips in between. It's pointless me doing this whole thing in time lapse. I'm just gonna kill my battery and the video is gonna just be way too long on YouTube. Yep, pretty much any of you guys that are wanting to do this know already how to weld, so I don't need to teach you on that. All right, that's the one side done. As you can see, I built up the whole heel just by about 5 or 6 mils. I think it's about 3 or 4 passes, just because obviously the heel was quite a little bit smaller than the body over here. So yeah, but I mean, you can see, sorry, the lighting's pretty bad. There you go. We have built up, and then the last, I would say 3 layers, I've just done a weave, you know, just building everything up. So there you have it. It's coming together. Now I've got all that junk to do, so that's probably going to take me a while. It's now 11:45, so that'll take me until the end of the day basically, and then I don't know. I have to do that first before I can do this, but yeah, that might have to be tomorrow's job. Okay, so here's ambient, 26 degrees Celsius or 78 Fahrenheit. So the heel, like I said, is quite hot. I don't need to really watch my heat on the heel because that is 260-ish, 265. So the body of the anvil is actually quite cool, you see. Have a look on the horn. So I went to have a little bit of a lunch break, and I came back and I did a few welds, and they're fine. The welds are taking well, but I thought it just felt a little bit cold. You can sort of tell, you know, the way your welds are adhering and opposed to the way they were before. So yeah, I thought I'd just put a little bit more preheat in the anvil. I did measure the temperature, and it's around about 100 all the way throughout. So I want to get it up maybe just by about 50 degrees, and then I'll carry on welding, and then it'll obviously keep its temperature. So, but yeah, there it is. Starting to look like an anvil now. Once all that's filled in, it'll really come together nicely. It was the same on the last one. It sort of looks like, what the hell's going on here? As soon as that's filled up, it changes the whole perspective. Let me just see. There you go. Okay, so we're getting there. As you can see, I've filled in there, and then I'm just trying to keep it all at the same level throughout so that I'm building up, you know, all together. I don't know if that makes sense. The lighting is pretty bad here, but so basically, I mean, I filled in there, and then I had a hollow here. You can see how deep it went there. So basically, I've just started in the bottom, and I've filled up. So now I can sort of start, you know, do a pass there, and then just fill, and then obviously over here I just weave, you know, just to fill the gaps. So yeah, I don't know, I don't really have a plan here. I'm just taking it as it comes. Obviously I need to get the metal up to that level, you know, I need to fill up there but as well. So that's basically what I'm heading for. I'm just throwing in steel and making sure I'm just working up evenly and I'm not leaving any gaps where I won't be able to get welding at a later stage. So this is how we're doing so far. Just filling it up. Just filling it up. Okay guys, getting there. Sorry, I know this is a little bit different to how I filmed the last one. I see absolutely no point in trying to time-lapse this. Yeah, I'm literally just welding this in there, but as you can see, it's going in really nicely. I filled up that big gouge. I can weld along there and then just go. So that's what I'm doing now. Just made this a little bit easier for myself. So yeah, you can see on the wrought iron, I do get a lot of this like silica stuff over there, so that's why I got my chipping hammer. So after every pass, I sort of just go and I try and remove it. It doesn't mess with the welds too much, you know, you can see it there. It melts, you know, but I just like to try and get rid of it because obviously the cleaner my welds can be, the better. So alrighty then, the heel is on. There you have it. That was a crap ton of welding, I won't lie. Wow. It is now 4 o'clock. I'm packing up to go home. It's very hot still, obviously, just finished welding. So yeah, I'm gonna see if I can get one of the guys from next door to help me put this in the sand so it can slow cool overnight. And then in the morning, I need to now do all of this, pull all that up. So fun times ahead. So went next door, no one there. So there's no ways that I can get this thing off the table myself. So I just lay it down, shoved sand underneath it, lay it on top and covered it up. I think what I'm going to do is just get some empty Nan tubs, formula tubs, fill them up with sand, and then just plunk them on top of each of those feet. I think I'll do that. I'll take a pic when I'm leaving. Okay, so that is the first pass right throughout. Now it's just full. What I did is I just did a pass over all the wrought iron just so that it adheres nicely, and I stood it up like this so that I can get it to, you know, really settle into that wrought and bond nicely. Now I'll be light upside down again. I think what I'll do is I'll build this up a little bit more, and this hollow here, you know, it's quite a lot more hollow there than it is that side, so I'll get it about the same, and then we can just spin it upside down and do passes again. So finally the inevitable happened. I ran out of wire, so there's a new fresh roll wire that I've just put in. So yeah, thought I'd just quickly show you guys how this works, and then it'll come out of there. There it is. Now we just assemble the torch again and we can go for it. Okay, so I've built up, obviously remember that number was right on the where we were off, so I've built that up about 20 mils, and I've sort of built this side up similar to that side so that I have similar shape, because now I turn this whole thing upside down and then just start in there and just add and then get this, you know, round. There's no easy way of doing it. I'm just trying to work symmetrical as possible. So like this was lower than that, so I just try to build this up so that I can run straight passes, because obviously the more straight passes, the easier, the quicker. So around about halfway there now. You can see this side where I've built up all of that already. Now what I'm doing is I'm just doing 1, 2, 3 passes, and then I start up again here. I do 1, 2, 3, 4, 5, I think. 1, 2, 3, 4, 5, 6. So yeah, I do 3, and then I start at the top again, and then I do 6, and then all I'm doing is I'm raising it up like that so that I'm building upwards, you know. That's how it's looking. It's definitely going. I'll get this finished today, but I'm not going to touch the face. It's quite a bit of welding this. Okay, so this is it. I've tipped it up right now, so I'm going to do exactly the same as what I was doing there. Yeah, so I'm going to do 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. So I can build this up like that, and then we can start getting rid of that corner. So we're definitely starting to take shape. Starting to look more and more like an anvil. What I'm going to do is I'm going to do 1 bead there, and then there and there. 1, 2, 3, 1, 2, 3, 4. So start in the middle, do 1, 1, do another 1, 1, 2, 1, 2. And then that way we're now building up in the middle and then spreading out that way. Alright, so all the filling is done. Now, when it's cool, I'll grind that flat, because As you can see, it is higher than the face. So, and I'll grind down in there and then preheat again for the last time, and then weld the stainless in and then hard facing, and that's it, done. So this genius right over here forgot that I have to still build up this horn and the cutting table. Cool, so that's that. Have a look from here. We'll grind that off over there to match the horn, match the beginning of the horn to the end of the horn, and then grind that there on the cutting table until it's flat. So yeah, then I had to build this corner up because that was quite far gone. Doesn't look like much now, but as soon as you start grinding it, then it starts taking shape quickly. I'm gonna put it in the sand now overnight, let it slow cool. So what I've done is I've made a template of the anvil just by lying it over and putting this piece of cardboard underneath it. I've tried to just sort of freehand and then do that, but like that. But I was getting a lot more material to remove this side than I was this side, so I thought, you know what, I'd rather just double check it. So I made a template of this side because this is the side that obviously has the least amount of material. So this is the side obviously we can't remove as much as the other side. So whatever we do, we want to reference it to this side over here. So I just made a template which takes me to this, and it came down like that, and then almost like at that sort of angle. That is the handling holes. So I've marked them both sides. This is the horn on this side. So I've just quickly taken a template like that, and I've just sort of angled it right to the edge of the heel. So now what I'll do is I'll cut this out with the scissors, lay it on both sides, mark this over here on both sides, and then I'll know exactly where I stand. Okay, so I'm pretty happy with that shape. That's quite nice. I've taken all the Sharpie marks off except for that one because I have to build that a little bit over there, and then I have literally one bead that I need to do in here, there. Let's just do one bead in there so that's fine. Doesn't have to be done, but why not? And this side is looking cool too, so there we go. The reason why I've done all the grinding first here is so that when I preheat to do the face, if I did need to do any full work, such as this one bead and this over here, then at least I've got the preheat to do it. If I finish the anvil up, which I found last time, and then I have to do a little bit of filling after I've ground, it's another preheat. So I thought I'd rather do the grinding first, then I already have preheat, so I can finish up whatever build work needs to be done. It's been well over a week now since I welded on this anvil. We've had quite bad load shedding, which is our scheduled power cuts. So I don't have enough time between the scheduled power cuts to weld the face. So I'm just waiting for, and the generator doesn't power the welding machine very well. So yeah, just waiting for better schedules to come out, so it'll allow me enough time to weld everything that needs welding. There's a little bit over there that I need to build up, and then it's just the top, which I need to do with that stainless wire, and then I need a hard face at the same time. So I need to do the stainless and the hard face. I'm just waiting on that. Everything else is done. It's sanded. The horn is done, sanded. This is done, finished. So that one's done. But what I thought of doing is you guys voted that I do this one of my dad's next. So I brought it in. There's not much to do here. So I thought maybe while I'm welding on the other one, I'll preheat the other one first. Then while I'm welding it, I'll preheat this one. And then I can just weld up this, because I don't need to do any mild steel work on here except for the horn, or the cutting table. I'm not even going to touch the horn. The horn is fine. So I'm going to do this cutting table. That'll be mild steel, but there's not much. Then I need to do stainless over here, and then hard facing on top, and then a little bit of stainless and hard facing in there, and then that's basically it. So I thought I'll prep this one so that when I have a good electricity schedule, I can do sort of 2 birds with 1 stone. This will be a separate video, this one. I just thought I'd show you guys where I am with the other one and why I want to start this one without having finished the other one first. That's my reasoning. So I'll start filming me just prepping this. It shouldn't take very long at all. Then we can have them both prepped for weld, so that as soon as we have the power, we can do the welding. All right, so today is the first day in about 3 or 4 weeks that we have power the whole day with no scheduled power cuts. So I am gonna do the welding on the anvil today, the stainless and the hard facing. I'm gonna see if I can maybe do 2 anvils, but I don't think so. I'm not gonna get ahead of myself. I'm just outside because it's quite noisy in there. I'm gonna just video the electricity meter to see where we're at before I start welding. They are busy with grinders in there, but that doesn't draw a lot of electricity, so we're just gonna factor that into the calculation, just so I can basically get an exact cost on what it cost me to fix that anvil. So I think what I'll do then is I'll weld 1 anvil, get that finished, and then if I need to do another one I can, but then I'll take an electricity meter reading after I'm finished with the first anvil, just so that we can factor in that cost, because otherwise if I'm going to be welding the whole day on 2 or 3 anvils, then I've got 2 anvils prepped, but if I'm going to be welding on 2 anvils, it's not going to give us an accurate reading on what it costs to restore 1. So that's what I'll do. I'm going to head in there now. It's quite noisy, but bear with me. Okay, so that's where I'm happy at. I just did 3 little passes, just tweaking my voltage and my current, just to see where it's welding nicely and not building up too much material, but also sinking down nicely and getting good penetration. So it looks like that's about it. So I'm gonna start welding. I'll show you guys what I'm wanting to do. So that was my first attempt over there, and that was my second pass, and that is my third. So I'm quite happy with that. That looks nice. It's not welding too high. You can see there, that was building up a bit too high. I'm gonna have to take down a lot there. That is welding quite nice and flat, so I'm not gonna have to grind too much before I hard face. What I'm gonna do is I'm gonna fill in these hollows now, and then I will do the whole face with this stainless wire. And then after that I will then do the hard facing. You can see here I have to fill all that up with this stainless as well, so I'm just going to give it a little bit of strength, And yeah, this over here, mild. So I will do this last. I'm just going to run a few beads of mild over there. I'll just do that with my dad's machine, which is in there. I'll just run an earth across and then just quickly done, mild, finished. So but that'll be right at the end. There's still quite a dip over here. I've marked it with chalk, but what I'll do is I will run one bead and then the bead on top. But it's not quite deep enough that I can run beads here. So what I'm going to do now is I'm just going to quickly flat this with a grinder, just to take down any super high spots, get it around about the same, sorry my angles are a bit weird here, around about the same level as the face, the rest of the face. So not a hell of a lot. I'm going to just do this with a big grinder quickly. I'm going to stand on the table, just take it down. I'll film that, and then I'm going to just start running beads. I'm probably going to just run beads along like this, just so that it's not as long of a bead, and then I'll just weave it in as well. I just want one pass on top. I'll probably do 2 passes here, but everywhere else I'm just going to do 1 pass. This stainless wire is welding much better than I thought it would. I'm not really having much of an issue with it, so yeah, I'll do that. And then on top of that, again, I'll just flat any high spots if there are any. I'm going to try and weld nicely so that there's not any excessive high spots, and then after that, hard face on top of that, and then that's what we'll grind down. As you can see, I haven't taken much down, very little over here, just a little bit there, basically just until my disc touched the original face, and then that from there I'm going to now start doing passes. So over here I'll do my first pass around here, and then I'm going to go over the top with everything else. So that is the stainless filler done. Did all the passes on the face, and then I just did a pass around the corners just to build it up. You can see there's a high spot here. That's where I did those 2 passes. I did the pass underneath, and then I did a pass on top. So there's a little bit of a high spot over there. I'm just going to take that down with a grinder, just on the small angle grinder. I'm just going to take that down a little bit so that when I put the hard facing on, everything is going on pretty much flat. Yeah, I'm happy with this. I don't have to prep this at all. I can just go straight over the hard facing as soon as I've just ground that little bit. So let me get a little bit of chalk, and then I'll show you guys what I mean. In a second. So looking at it in the light, see, it's there. That's it. That is the bit that I need to take down. So I'm just going to quickly whack that off with the grinder, and then I'll set the arc weld up, and then I can start running hard face. I just took it down over there, and then I just went over with a grinding disc just to get all the high spots flat. And then I thought I'd put the straight edge on. Glad I did, because I have got a gap there. So what we do now is we grind a little bit off there and a little bit off there, and we might have to put in a pass or 2 there, but I don't think I'll have to. So I'm just going to take down over here, there, there, then on this side, middle I'm going to leave. Don't want to take that down too much. So that's that. That's what we're going to take down. I'm going to just take that down with a big angle grinder and see how it goes. I've taken it down over there and over there, and I have to build up there by that chalk line, and a little bit here by this chalk line. You can see there, a little bit of a hollow, the rest of the gap is good. And then this chalk line over here, you'll see there's a bit of a hollow rising. the rest of the gap is good. So I'm gonna quickly just give it a real quick pass over there, and then we're good to go for hard facing. Satisfied here, now I can start hard facing. Very small gaps, less than 2 mils, so I'm happy. So I am done, I'm finished. Hard facing is done. I built the cutting table up just a little bit more. I did another 2 passes, well 1.5 was low here, so I've done 2 here, 1 at the back. And I thought it'd be nice to actually step it up from the horn a little bit, especially because I obviously built up another 2 passes onto the face, so just so that it's not such a big drop from the face to the cutting table. But there it is. Have a look at that top flat. Frickin' awesome. So now we'll slow cool it in the sand, same as always, and then I will clean it up as I get time and gaps between things. So just thought I'd make a start at this. I flattened this down. This is nice and level. Just so that you guys know, this table is perfectly level, but what is not level is the feet. Remember, I have to still take down that foot over there, so sort of just getting everything. I know from working on my table and when I welded this that everything was level, and I welded relatively level. So all I'm doing is I'm just getting everything flat, then I will do the foot so I can get level, and then I'll work the face from there. But you can see it's not terrible. Obviously I've got all that movement there, which is on the feet. But yeah, you can see just from the gaps underneath that cutting table is nice and flat. There's a tiny bit over there, but if I have to, I'll just weld that in. I don't need a preheat for that because this is mild. So yeah, and then I just started grinding off all the high spots, but this is why it's so important to get it as close to perfect as possible before you hard face, because you can see I have almost no gap the whole way through. So all I now need to do is work this down until my lowest point is worked out, and then it's done. So it's always good to, yeah, it's exactly the same as anything. You know, if your prep work is good, the end product goes quick, and it's perfect. But if your prep work is bad, then obviously you have issues in your finishing. So the feet are sorted out. You can see there's no more rock at all. No more back and forth, which is great. It was only about 3 mils, so not much at all, but enough to create some issues. You can't get a level, you can't put a level on the side of the anvil, because a lot of them are like this, where they go up that side and then up that side. So it's not like they're perfectly flat on the sides. They weren't made perfectly flat on the sides, these wrought iron forged anvils. Okay, so let's have a look at the face. The face is level right the way through, which is great. And this side over here is off slightly, but you can already see where the high spot is over here, because it's smooth, and then obviously over here there's a lot of lows. I already know that that's a high spot, and this just confirms that. There we go, that's my gap. So it's a mil, you know, it's like 1 millimeter out. So which means that I have to grind this 1 millimeter lower than the rest of it. So what I'll do is I'll work this back and forth, just a few passes, and then I'll just start working everything down together. But this is how you dial it in. It's not very difficult. You just have to keep on using a level. Make sure you have a level surface to begin with. So make sure your base is level so that everything else stays true. So I've put the cup grinding wheel in, so I can start on that now. I may still change back to that grinding wheel just because that takes off a lot more material than this one. But I'm looking for to just get a flat surface now, and this gets it perfectly flat. So as soon as I've got a flat surface, I can then see where my highs and lows are, and then I can put that grinding wheel back on, take more down. I'm pretty close to level, which is good enough for me. There are some spots where it's a little bit out, but I can see there I need to take down a little bit over there. And then the cutting table is also pretty good. You come down also a little bit more this side, but it's getting there. I'm happy with the gaps, really good gaps, nice and level. So we just carry on now with a cup grinder, give that a few passes, and then see how we're going from there. But generally it does come together quite quickly now. All we're doing is we're taking down all the high spots until we get to the lowest point with all of this. Just carry on taking it down. I mean, if we take the whole face down by 1 mil to get to the lowest spot, which I'm guessing will either be that one or that one over there, it's not much at all. Everything is looking good. Got all the marks out, most of them. See there's a little bit here, a little bit of a low there. But this is all done with the big grinding disc. I'm gonna now put the cup grinder on and just finish this off. We're getting it. It is slightly crowned this way. I'll show you guys after I'm done with the cup grinder, but it's completely level length way of the face. So very happy with that. I haven't ground this off because what you do is you find that when you're grinding, it sort of, you know, you do score the edges slightly. So I leave the build up, do the face, and then grind off the edges so that you don't have very rounded edges. Then you can get exactly the type of edges that you want. So leave the excess over there so that when you do slip up like there, you're not stuffing up your nice edges, your nice crisp edges that you want. Grind that off afterwards, we'll come into there and then we've got nice crisp edges. So that's how that works. Cup grinder time, and then looks like it'll be done. We're getting real close now. You can see the uniform grinding pattern. You can see around the Pritchell hole, so there's a little bit of a low spot. You can see the difference in grinding pattern, and then a little bit here and there, and then it's pretty consistent. There's a tiny bit there, and then there's a bit of a low there and a bit of a low over there. You can see from welding there are some very small little holes, but I'm not going to worry about that. They are very small. So I will grind, I'll carry on grinding until I've worked out those lows as much as I can. But I mean, that's a fraction of a millimeter. You can't barely even feel it with your finger. All that's left to do now is to polish the face with a belt sander, get it nice and flat, and clean up around the Hardy hole and the Pritchell hole. do that with a die grinder. But there we have it. All the edges are sanded down, or ground down and then sanded, just polished. Cutting table is done. Horn is just polished. I did polish it before, but I got some berries on it, so I just went over that again. But yeah, there it is. Haven't even checked this yet. But yeah, I'm just checking for flat. Nice and flat. The face is perfect. Perfect right through, which is really, really nice. Let's just see this way over here. No gaps at all, and that follows right the way through. So yeah, all that's left now is to just clean this up. There are still very, very, very tiny bits from welding, just to give you an idea on scale of these little dots. This is a scriber. So you can see the size of those dots compared to the smallest tip on the scriber. I don't even think that the factory face was polished to be this good. There's quite a few there. These are the biggest ones that there are, but still completely workable. And there's a very small blemish over here, right in the cutting table. That's just from a weld bead, you know. But see how nice the cutting table came out just by me building it up those last few passes. Just gives it it's defined, you know, it's just defined. Just got the anvil into the electrolysis dip. I've got it sitting up on with its horn at the bottom there and its foot, and then the heel is sort of up, just so that the electrolysis can get under the feet and, you know, under the base of the anvil and pull rust off there. That's the tip of the heel over here. So that is that. I'm not going to show you guys too much on electrolysis. If you want to see more and you haven't seen these videos before, you can just go onto the YouTube channel, and then there'll be a whole bunch about electrolysis over there. There's one video that I did especially for electrolysis. Anvil's been in here now for 3 days, so I'm going to pull it out today and wash it off, wire wheel, let it dry, rust converter, linseed oil, done. I've just made this chart on how I've done my costing. So gas we used out of our gas chamber, but it would not have been more than a 9 kg bottle. Just said less than 9 kgs. Factor into your cost that you're going to use a full bottle. You're not going to run over that price. Electricity, welding and grinding, I used 23.3 units. And the electrolysis, I used 11.8 units. I found the MIG welding machine used substantially less units than the arc welder. When I did the hard facing on the top and then the electrolysis, that's when I used the most electricity. So it seems the arc welder is quite heavy on electricity. And then mild steel, I had a roll in, I changed the roll and I've used some of that roll. So worst case scenario, factor in that you're going to use a 15 kg roll. I don't think I used 15 kgs in this anvil, but I factored that cost at 15 kgs. The 309, it was a brand new roll, so I know that that roll was 15 kgs new. I weighed it and it's 2 kgs lighter. So that means I used 2 kgs of the stainless rod, and then I used 35 hard facing rods, which comes to a kg. My abrasives, this was sort of just a guesstimate because I actually didn't keep count, and like you guys saw, I used old grinding wheels to get in tight corners and stuff, so I've just worked on an average. Cutting discs, I probably used about 4 small ones. I know that I used 1 big one when I cut the heel, the bevels and stuff like that. So that's I've just done that. This was the power saw blade. This was actually the most expensive part about all my abrasives, and that was only due to my ignorance that it broke. So I factored that cost in. Grinding discs, I probably used in total 2 small ones, and I used 1 big one when I was doing all the prep work, and then obviously the finishing I used a new one, but I didn't use a whole one, if you know what I'm saying. If you started off with a new big grinding disc, you'd still have some left. And then all my cup grinders and stuff, those lined up over here. So I still have a lot of life left on them. Because I don't do grinding with them, I just use them for flatting. So those last me a long time. So I'm not even going to factor that cost in. And then sanding discs, which are just flapper wheels, I've just done 2. I don't think I'll use 2, but worst case scenario, I'll probably use 2. So there we go. The belt sander, I didn't even factor that cost in because that belt is still perfectly fine. I can reuse that, and it'll probably end up being eaten out by wood or something else that we're doing. Okay, so I've got here my pricing. I've got South African rands, and then I've got British pounds and US dollars. Okay, so gas. A full 9 kg gas bottle is about 225 Rand, depending on where you get it from, which is 9.5 pound, $12 for gas. Electricity. Now, this is also depending on where you live, but I used total of 35.1 units, which comes to 136 Rand, or 5.7 pounds, or about $7. I've just averaged up on the dollars because it was like all higher than 0.5, so I've just averaged up for the dollars. Mild steel, a roll cost me 675 Rand, 28.6 pounds, $35. I used 2 kgs of stainless wire, which is so I just divided. I said 15 kgs, so it was an X amount for the whole roll. Divide that by 15 times by 2, so that's how I got to that price. So it's 250 Rands worth of welding wire. 10.5 pound, $13. Hard facing rod, I used 1 kg, which is 60 Rand. 2.5 pounds, $3. And abrasives, I just averaged, it came to just under 500, so I just said 500 Rand for abrasives. So that's 21 pounds and $26. So that's what it cost me, a total of quickly just worked out my totals. So a total of 1,846 Rand, which you can't even buy an anvil for. 77.8 British pounds, or $96. So that's what it cost me to fix this. So I paid 2,500 Rand for this anvil when it was broken. A friend of mine transported for me, so I had no transport costs added in that. It cost me 1,846 Rand to repair. So in total, I've got 4,346 Rand. You can't buy a damaged anvil for that price here locally. So total, it cost me 183.8 pounds for that. Completely restored. That's my cost in that anvil, or $225. So that's a really good price. That is my cost in it, but obviously I haven't factored any time. So I haven't charged out for time, because if I charge out for time, I mean, like I said, 6 months on and off in all my spare time. That's what I've been doing. So definitely not worth it if you factor time into it. But this is a labor of love for me, so it's completely worth it. And I can sell this now for at least double what I've got in it. That still doesn't cover my time, but I'm not doing this to make money. I'm doing this because this is now a usable anvil that someone can enjoy. So that is what it costs to restore an anvil. There we go. I will just attach a little bit of footage after this of me beating some nice hot steel on here as soon as the linseed oil is dried a bit, just so you guys can see that the heel is not going to just fall off. I have had a lot of questions saying, oh, you sure the heel is going to last and it's going to stay on? Well, I did a full penetrating weld on this, so it's going to be stronger than what it was before, definitely. So there we go. That answers your question. I'll attach a video after this of before I dipped it. I had it in the room here with the other anvils on a stump, and I tested the ring. I closed all the doors so that it could resonate nicely, so I'll attach that here. So as you can hear, that thing rings like a church bell, which is really nice. So now just for forging a little bit. And that's it, guys. Thanks so much for watching. Really appreciate your time. And if you liked the video, please give it a thumbs up. And if you want to see more, please subscribe.